Hello everyone and welcome to Mathematics for You. In this video, let us solve a question from geometry. The question is really beautiful and that you are going to realize when we will trace the curve. Chale, let's start with the question. The question says that A1, A2, A3 up to A12 is a regular dodecagon with side length 1 and center at O. So I'm just going to trace the rough sketch over here. Start karte hain. Dodecagon I'm going to trace, regular hai. That's why I'm taking the help of a circle first of all. So 12 points at equal distances, I'll try to trace. These are the 4 points. And then you can see that these are the points that we can trace to make a regular dodecagon. So these are the 12 vertices. I'm going to join them to make a regular dodecagon. So the question is about a regular dodecagon. That's why we are tracing it. Okay, so this is regular dodecagon. I'm just going to mark the vertices as well. A1, A2, A3, A4, A5, A6 till A12, you will be marking all these vertices, right? So let us read it once again. The question says that there is a regular dodecagon. So the main figure of this question is the red regular dodecagon that I have traced here. What is the area of the region covered by the circle A1, A2, O? O is the center of the circle and also the side of the regular dodecagon has been provided as 1. ठीक है, ये हमें 1 provide कर दी गई है. So they are saying that you are tracing the circles A1, A2, O, A3, A4, O, A5, A6, O, and so on till A11, A12, O. ABC denote the circle passing through the point ABC. So which circles are they talking about? They're talking about the circle which are passing through O, A1, A2. So I'm just tracing the rough sketch again. This is the circle that we will be having, right? This is the kind of circle that we will be having. Another circle that I will be tracing is with A3, A4 and O, right? A3, A4, O. This is the second circle that we will have. Then we will have the third circle passing through O, A5, A6. This is the third circle that we will be having. And so on, like this, we will have 6 circles, right? So total 6 circles we have to trace. So 6 circles you will have to trace. The last one is going to pass through A11, A12 and O. A11, A12, O. Let me make it a little better circle. This is the circle that we'll be having, right? Again, let me try it once more. A proper circle I will be tracing. I'll just try to trace it. Then I'll show you the exact figure what we are going to get. So like this, we will have total 6 circles. And the question says that you have to find out the area of the region covered by these 6 circles. So they are not saying that you have to individually find the area of the circle and then you have to multiply it with 6. The region covered by these circles, we need to get the area of that region, right? This is the question that we are handling now. How we are going to solve it? Solve करने के लिए देखो, अब I'm going to show you the exact figure that will help us in identifying and solving the problem as well. So this is the kind of figure we will be getting. So let me mark all the important points. This is the center O. Then I'm going to write it as A1. This is A2. This is A3. This is A4. A5 and till A12 we have to go, correct? All these points we have marked. What is the side length they have provided? They have given me the side length as 1. The area that we need to calculate, how we are going to calculate the area. The total area of the region bounded by the circle. The region covered by the circle ka area I need to find out. So what I will be doing, I will be calculating the area of this dodecagon. The regular polygon ka area hum log nikalenge. Calculate the area of the regular polygon. And in that polygon, now you will see that there are certain regions whose area we don't have to calculate. We have to remove it from the region or the area that we are actually calculating in regular dodecagon. So ये जो red regions है ना, इसका area मुझे regular dodecagon से remove करना होगा because it is not constituting a part of area of the region bounded by the circle or the area of the region covered by these 6 circles. So how many such regions are there? You can see that आपके पास ऐसे 6 regions हैं, 6 red regions whose area is to be removed from the area of the polygon. But apart from this, I also need certain area which is not being calculated in the area of the polygon. कौन सा region है? Now you can see that I'm marking it or shading it with the green. These 6 green regions का area I will have to evaluate separately, right? And will have to add in the area of polygon to get the exact answer to the question. So this is my way of handling the question. This is how I'm going to handle it. So हम 6 green regions को इसमें add कर देंगे so that we will get the exact answer. Okay, fine. Let us start with the area of the polygon first of all. So first of all, I'm starting with the area of the polygon. And because it is a regular polygon, I can say that my answer for area of the polygon will be equals to 12 times the area of triangle OA1A2. What is the area of triangle OA1A2? That also we can easily identify. Because it's a regular dodecagon, each side is going to make an angle of pi by 6 at the center of the circle. So this angle is pi by 6. I don't know the radius, but can be calculated. So I'm just assuming that let R be the radius of the circle circumscribing regular dodecagon. ठीक है, जो regular polygon है उसको circumscribe करने वाले circle का radius I have assumed R. Okay, so I can say that answer will be 1 by 12 multiplied by 1 by 2 R square sine pi by 6. So I have written R square over here. I can say that the area of polygon turns out to be 3 capital R square. Okay, 3 capital R square area of the total regular polygon aa jayega. But what is the value of R? I need the value of R as well. So again, let us go back to this figure. How we are going to calculate this R? You can see that OA1A2 is a regular, in fact not regular, isosceles triangle, right? It is isosceles triangle. So when you drop perpendicular from O on the side of the polygon, the side of polygon will get bisected. Okay. I know that this side length is 1 by 2, correct? And now you can see the triangle which I'm shading with blue. This is the triangle I'm shading with the blue. You can look at this triangle. It is a right angle triangle having the hypotenuse as R and the vertex angle has now become 15 degrees. So I can write that when I calculate R sine 15 degrees, it turns out to be equals to 1 by 2, correct? You need the value of R now. So R can now be evaluated as 1 by 2. Denominator sine 15 degrees. What is the value of sine 15 degrees? It is root 3 minus 1 by 2 root 2. So you can cancel this too. So what is the radius of this triangle? Or what is the radius of the circle we are considering here? The radius of the circle that we are considering here turns out to be root 2 upon root 3 minus 1, right? So side length 1 tha. When you drop the perpendicular, it will become 1 by 2. The angle has become 15 degree. R sine 15 degrees is 1 by 2 and I calculated the radius. So whenever required, I'll come back to this value and will put it over here, right? Chale, polygon ka area to aa gaya. Now I need to remove the red areas and have to add the green areas. So for that, now I will be removing this triangle because I have to show you how we are going to calculate the area of the red and the green region. Now, first of all, because of the symmetry, it's a regular dodecagon making an angle of 30 degrees at the center. Each side is making an angle of 30 degrees at the center. And each of those sides, they are making an angle of 60 degrees at the center, right? So I can say that these 6 circles जो हमने trace किए ना, they are so symmetric circles that if I join the center with the middle point of the chord, the corresponding chord, which is also the side of the regular polygon, then between these 2 consecutive circles, I'll be getting the angle as 60 degree, right? The angle 60 degree आएगा. Why? Because consecutive sides होता तो centers के बीच का angle pi by 6 plus pi by 6. That is how we are going to calculate ना. तो आपके पास कितना angle आ जाएगा? Pi by 6 plus pi by 6. That means I will be saying that it is going to become twice of pi by 6. Correct? Okay, if this is 60 degree, further, the points of intersection, if I write them as P and Q and R and S and so on, then all these PQRS, the points of intersection of different circles, they are actually also the centers of the corresponding circle. Like if I want to talk about point P, then it is the center of this circle which we are talking about. Okay? This circle ka center kitna hai? P hai. If P is the center of the circle and this is 60 degree, then you can see that when I join P and Q, since it is isosceles triangle, symmetry says that every point of intersection PQRS is going to be at equal distance from the center. So we will have OP is equals to OQ. Since OP is equals to OQ, I can say that this triangle is becoming an equilateral triangle, right? This triangle is an equilateral triangle. But now my question is, what is OP? What actually is the radius of the circle which we have traced through OA1, A2? I need to get the radius of the circle. इस सर्कल का रेडियस अब आप कैसे निकाल सकते हो? तो रेडियस निकालने के लिए अगेन इट्स वेरी सिंपल. See what you have to do. A1, A2 are 2 points on the circumference of the circle. The chord A1, A2 is making an angle of, it is making an angle of 30 degrees at the circumference. So how much angle is it going to make at the center of the circle? If you are taking this as the center of the circle, then this angle is going to become 60 degrees. This is nothing but the radius of the circle. Both sides are equal. I will say that triangle again has become an equilateral triangle. Equilateral triangle ka one side you can see that it is 1. So I can say the remaining sides are also going to be 1. If the remaining sides are 1, that means it clearly indicates that the radius of all these small circles that we have traced are actually equals to 1. ठीक है, जितने circles यहाँ पे 6 circles हमने trace किए ना, उन सब का radius is equal to 1. And because the radius is 1, now I can say that this side length PO or OP is equals to OQ is equals to PQ. ये all are equals to 1. All these side lengths are 1. Okay. Now, if it is 1, then again look at one more thing. We have PQ. Okay. PQ length is equals to 1. The same thing is going to occur for the remaining up pair of circles also. The consecutive circles, if you take, you will get the similar kind of result. So PQ, distance between these centers, like QR will also turn out to be 1. So I'm actually calculating one red area. And after that, I'm going to multiply it with 6. So concentrating on this red area, how to calculate. For that, what I have done is, I have evaluated that PQ length is turning out to be 1. We also know that PA2 is equals to 1 because A2 is a point on the circle. P is the center of the circle. Similarly, because Q is the center of this other circle, this QA3 length will also be equals to 1. And A2, A3 is also equals to 1, right? A2, A3 is also 1. So I can say all sides are equal. So at least PQ, A3, A2 is a rhombus. PQ, A3, A2 is a rhombus. Rhombus hai to particularly is it a square? That is what I need to check. How we are going to check that? Again, it's a very simple thing. You just need a simple geometry. What we are going to do, we are going to find out this angle. Okay, we need to find out this angle. How we are going to do that? For identifying this angle, we know that this angle. Can you see the angle I am marking here? The angle which the triangle OA1A2. The angle of the triangle OA1A2, base angle of the triangle is 75 degrees. Why is it 75? 75 because obviously the vertex angle is 30 degrees. Isosceles triangle, so base angles ka sum should be 150. Each angle will become 75. Each angle 75 means I can say that this angle is also 75, right? This angle is also 75. But out of this 75, 60 degree has been used. Right? This 60 degree has been utilized by this small equilateral triangle PA1A2. Yani ye jo bacha hua angle hai, this angle is actually only 15 degrees. If it is 15 and this is 75, then can I say that total this angle, the angle that we are talking about is PA2A3. This angle is actually equals to 90 degrees, right? PA2A3 is 90 degree. Now, if angle PA2A3 is 90 degree, so I can definitely say that this quadrilateral PQA2A3 is a square. We have this quadrilateral, a square. Okay, I have the square and now you can see the figure here. I'm going to make this figure separately. Okay, ek square bana lete hain pehle. So I'm just making a square over here. So let us complete the square. So ye raha hamare paas square. What kind of square do we have? The sides are like A2, A3, and this we have taken P and Q. And after that, we have also seen that circles are going like this. Take a one circle ka portion. This is a quarter of the circle because side length is 1. The radius of the circle is same. The other circle is going like this. What I need to calculate is this area, right? I need to find out this area. How we are going to calculate it. So this point of intersection I'm taking as capital X. Okay. We know that P and Q are the centers of the corresponding circles. How we are going to calculate this shaded region ka area? For that, what I will be doing is, I'll just join X with P and Q. So just concentrate here. We are joining P with X. So let us join P with X. and join Q with X as well, right? Okay, what can you say about this side length is 1? This is also 1. This is also 1. Because nothing, P is the center and the point X is on the circumference of the circle. That's why we are taking this side length as 1. But all side lengths 1 indicates that this base angle is going to be 60 degree, right? Base angle is 60 degree. 60 degree angle is matlab, I can easily find out the area of this equilateral triangle, correct? Now, we are left out with the arc PXA2 and the arc QXA3. If I calculate these two areas as well, then along with the equilateral triangle and these two arcs, if I subtract it from the total square of area 1, I will be getting the leftover area, right? I'll be getting the area which is required in the question. So arc PXA2 को हम लोग कैसे लिख सकते हैं? This is equals to half side square. अभी side square means you have this arc, तो radius का square which is 1 and the included angle. What is this included angle? You can see total was 90 and 60 already covered. So we are left out only with pi by 6, right? We are left out only with. Similarly, our QXA3 का area कितना आ जाएगा? It will be 1 by 2, pi by 6, right? So now we can find out the area of the region A2XA3. How we are going to write it? Total area of the square, you can see that it is 1. One may say, I'm going to subtract now, first of all, the area of the triangle PQX, which is equilateral triangle with side length 1. I'll also be subtracting the areas of the two arc or the two regions of the circle, which has areas equals to this one. So pi by 6, I will have to subtract from it. This is the area of one red region that we have calculated, right? This is one red region that we have calculated. So you just have to multiply it with 6. So I'm multiplying it with 6 to get the answer as 6 times 1 minus root 3 by 4 minus pi by 6, correct? This has to be subtracted from the area of the regular polygon, which we have already calculated. But now we have to add 6 times the green regions. Red regions we have subtracted, but now we have to add 6 times these green regions. What are these green regions ka area? Now it is again very simple to evaluate this area, because you can see that if I consider the arc, if I consider the arc of the circle PA1A2, right? If I consider this arc PA1A2, then it is nothing but a part of the circle OA1A2. It is a part of the circle OA1A2 having the radius 1. What I need to find out is the green region, which can be done as, first of all, calculating the area as half r square theta. What is theta here? Pi by 3. And from it, I'm going to subtract the area of the equilateral triangle, which has the side length again equals to 1. That is root 3 by 4. So when you evaluate this value, it turns out to be pi by 6 minus root 3 by 4. Multiply it with 6. It has to be added to the area of regular polygon, which we have evaluated. So now I can say that I have the area of the green region, I have the area of the red region. I'm just going to put it in this formula to get my answer. So chaliye, let us complete the question now. I'm going to put all these values. So let's start with the required area. What is the required area? Required area will be, first of all, the area of polygon, which we evaluated as, kitna aa raha hai bhai? This is 3r square. What is the value of r? We have root 2 by root 3 minus 1, right? So 3r square I'm going to write here. So required area mein first thing is 3r square. R square is root 2 upon root 3 minus 1 whole square, right? This is 3r square. So r we have already evaluated. I'm just going to put it over here. ठीक है. Next what? Now I'm going to write the next thing. So the next value that we are getting now is the red regions ka area, which is to be subtracted. So I'm going to subtract this area. So minus 6 times 1 minus root 3 by 4 minus pi by 6. And then I have to add 6 times the green regions ka area, which also we have evaluated. And the value that we are getting is 6 times pi by 6 minus root 3 by 4. 6 times pi by 6 minus root 3 by 4. So now we just need to write it in a proper way to get the answer in the final form. Can I say that 6 times pi by 6 will be added? These two terms will get added, while 6 into root 3 by 4 minus 6 into root 3 by 4, they will get cancelled. What we are getting here is 3 times 2 divided by root 3 minus 1 ka whole square. I'm just going to rationalize it. Numerator में I'll write root 3 plus 1 का whole square. Well, denominator root 3 minus 1 into root 3 plus 1. So basically 2 ka whole square. So I can write it as 4. Coming to the next term, we have minus 6 over here. Then we have plus pi and again one more pi. Correct? Let's move ahead. What do we have? We have here 3 by 2. Root 3 plus 1 ka whole square turns out to be 4 plus 2 root 3. And then we have minus 6 plus 2 pi. Right? This is what we are getting. Abhi, we have to simplify this one. How we are going to simplify it? You can see that this is actually 6, which can be cancelled from this one. And then we are left out here with 3 root 3 and plus 2 pi. Or you can say that finally the area bounded by the region or area of the region which is covered by all the 6 circles is turning out to be 2 pi plus 3 root 3. So here is the answer to the beautiful question, the beautiful circles that we have traced. And the final answer that we are getting for the area covered by all these 6 circles is turning out to be 2 pi plus 3 root 3. So I hope you must have enjoyed this question. So please don't forget to hit the like button, share the video with your friends, subscribe to the channel. See you in the next video. Till then, take care and bye-bye.